Find the coefficients a, b, c in the expansion here. The graph of the equation y equals x cubed passes through the points P and Q, which have x coordinates 2 and 2 plus h respectively. Show that the gradient of the chord PQ is this. Express this as a quadratic function of h. As the value of h decreases, the point Q gets closer to the point P on the curve. As h gets closer to 0, the chord PQ gets closer to being the tangent to the curve at P. Deduce the value of the gradient of the tangent at P. And part 4, which I'll leave you to read, finishes the question. So here's the question then. I paraphrased it all. That's part 4, which we'll do in a minute. But let's go back up to the first parts of the question then, here. Okay, so part 1 then. Let's have a look at that then. 2 plus h cubed. Let's use Pascal's triangle. So we'll do that then. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. There's the cube line. The 2 is the first term, so we do 2 cubed, 2 squared, 2 to the power 1. And we do h cubed in the reverse direction, h squared, and descend the powers. So these are the terms then. So that's equal to 2 cubed, which is 8, 12h, and then 6h squared, then lastly an h cubed. Okay, good. So a is the h value, a is 12, b is the h squared values, the coefficient 6, and c is equal to the number of h cubes, which is 1. So that's part 1. The graph of y equals x cubed passes through P and Q with x values h and 2 plus h. Show that the gradient of PQ is this. So P has coordinates 2 and 2 cubed, which is 8, and Q has coordinates 2 plus h and 2 plus h cubed. So gradient PQ then, which is what we were asked to work out. Let's just go back and check the question's okay. H, oh, P was H, and oh, this will be 2, won't it? Sorry, this is meant to be 2. It should say 2 in the question, I'm sure. And we've got that. Okay, show that the gradient is that. So the increase in y then is 2 plus h cubed minus the y value over 2 plus h, the x value here, take away the x value there, which is 2 plus h cubed minus 8 over 2. That's that. Good, so that's part 2. Express this as a quadratic in h. So part 3, gradient PQ then. Well, it would be this, take 8, so it's 12h, because the 8's will cancel, plus 6h squared plus h cubed. We could write 8 plus here, take away the 8, all over 2 plus h minus 2, and that should have been an h, of course. Let me just change that now. And an h goes here. And we can cancel by h, so this will be h squared then, all the way through on top, plus 6h, plus 12. So that's part 3. As h decreases, q tends to b as h tends to 0, pq tends to the tangent of b. Deduce the value of this tangent. So part 4, as h tends to 0, h squared plus 6h plus 12 will tend to just 12, won't it? So that's part 4. Now part 5. Karen uses the same method to deduce the value of the gradient of this, the gradient at 216 on y equals x to the 4. Take the first three lines, take P to be the point this, take Q to be the point that. The gradient of the chord is given by this, completes Karen's workings. Okay, so we need to do the same thing, don't we, I suppose? Same method, the value of the gradient at 216 is what we want. So 2 plus h to the 4 then, minus the 2 plus h, minus, I'm just going to go back to question 4 in the question to check I've written it correctly. Minus the 2 plus h, minus 16. So that's what I should have written here. Minus 16 over h, of course, because it was 16 there. I thought something was not correct in what I wrote down. There we go. Okay, so minus 16 then, here. So I think I've written down the question correctly, over h, which equals, now this fourth power, I better do Pascal's. I'll do it here, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. There's the fourth line. It's 2 to the 4, and 2 cubed, 2 squared, and 2 to the 1. And then the h to the 4 descends the other way in terms of its power. h4, h squared, h cubed, and just h. So we end up with 16 then, plus 8 4s are 32h, 32h, 6 4s are 24h cubed, 4 times 2 is 8, h to the 4, and then we've got 8h, this should be 3, and this should be 2, 2, 3, not good. But it's okay, we've got over it there, cubed, and then the last one is plus h to the 4, minus the 16 over h, which equals, divide by h all the way as through here, 32 plus 24h plus 8h squared plus h cubed. As h tends to 0, as h tends to 0, gradient PQ tends to 32. That's what we've got here.